Hi everyone, good evening. How are you? I'm Abhay Mahajan, your master teacher at Vedantu, and I welcome you all to this wonderful series called Beyond Textbooks, wherein we discuss things which are not there in textbook. I hope you all had a great weekend with Raksha Bandhan and Eid, and are now back to the normal, right? So let us do something interesting today, right? So we'll be doing a topic called functional equations, जिसमें बहुत सारे बच्चों को बहुत सारी problems आती हैं, right? Now, the requisite for understanding this particular lecture is to have a basic knowledge of functions. So basic knowledge of functions अगर है, then you'll be able to get this topic called functional equations. So we are doing, and we have divided this functional equation topics into two parts. So आज we'll be discussing some basic questions of functional equations, and in the next session we'll be doing some advanced functional equations, right? Okay. So as told, we be equipped with some basic knowledge of functions that is very much required to understand this lecture. All right. So let us start with the first question. So let f be a function from natural numbers to a set of natural numbers given as f of n is equal to n into n plus 1. So this is a function. It's a very simple question. So the question is, find the values of m and n such that 4 times f of n is equal to f of m, where m and n are natural numbers. So if you're seeing the recording, please pause this video for some time and then try on your own while I discuss the solution. Now this question involves a basic knowledge of functions to understand what this means, right? So this is a function from a set of natural numbers to a set of natural numbers, right? And also it would involve some basic knowledge of number theory, right? Okay, so we are given that 4f of n, 4 times the function of n is equal to function of m, where m and n are two natural numbers. So I need to find m and n satisfying this equation. So let us fill in the values. So 4 times f of n means n into n plus 1 is equal to m into m plus 1. M into m plus 1. So we need to solve this Diophantine equation. If I multiply this, so 4n square plus 4n is equal to m square plus m plus 1. So I need to solve this Diophantine equation. I need to find the integral solutions of this very equation. So how do I do this? So there are many ways. So one of the questions we've already discussed in one of the sessions before in Diophantine equation. So if you've not seen that lecture, please go to that lecture called Diophantine equation 1. Diophantine equation 1 and see the lecture. You'll be able to understand this question in a better way then. So how do we do this? So we try to minimize the variables. So n square n, we try to complete the square. So add 1 on both the sides. Add 1 on both the sides. So we have 2n plus 1 whole square is equal to m square plus m plus 2. M square plus m plus 2. So we need to find the integral solutions of this equation. Integral solutions of this equation. How do I do this? How do I do this? So 2n plus 1. So can I say this is a perfect square? So this is a perfect square on left hand side. While on right hand side, if you look at this expression, can I say, okay, so 1 is already added, I think. 1 is already added. So m square plus m plus 1. So it would be 1. So m square plus m plus 1, if we look at this, can I say this is less than or equal to m square plus 2m plus 1? And this is greater than m square. And this is strictly less than m square plus 2m plus 1. So if I add m is a natural number. So m square is less than m square plus m plus 1 is less than m plus 1 whole square. Now this very expression m square plus m plus 1 is a natural number which is lying between two consecutive perfect square. M square or m plus 1 whole square are two consecutive perfect square. And m square plus m plus 1 is lying between these two. M square plus m plus 1 is lying between these two. So that means this cannot be a perfect square. This cannot be a perfect square. Hence, this has no solution. So no values of m and n satisfy this, where m and n are natural numbers. I hope you got this. So this question was more of number theory and less of functions, but yes, functions was involved. Right, so this was a basic question. I hope you all got the solution and you are ready to face the second question, which is this. Now, f is a function from a set of natural numbers to a set of natural numbers, such that f of 3n, let me write this again, f of 3n is n plus f of 3n minus 3 for every positive integer n greater than 1. So n is greater than 1 here. Also, it is given that f of 3 is 1. And I need to find f of 12. We need to find f of 12. So how do I do this? So for f of 12, let us concentrate on f of 12. How do I get f of 12? If I put n as 4. So put n as 4 in this equation. So we'll get f of 12 as 4 plus f of 9. But f of 9 is also not given. So for f of 9, in this equation, put n as 3. So f of 9 would be, n ko 3 put karenge, it will be f of 6. And f of 6 is also not given. For f of 6, in this equation, put n as 2. So that is how you're going backwards. You're going backwards. So n as 2, so it will be 2 plus f of 3. And f of 3 is something which is given to us. So f of 3 is 1. So f of 6 would be 3. This would be 6. And this would be 10. So value of f of 12 is 10. So this is how you find the value of simple functional equations and the value of functions at a particular point using functional equations. Right. So these are very basic questions that we were discussing, and in the next session we'll discuss some good questions. Right. So the idea is to make everyone aware of what functions are and how do we solve the basic questions of functional equations. I hope you all got the second question. All right. We'll start with the third one then. So find all the functions. So this is a question involving functional equations. So we need to find all the functions such that f is a function from set of real numbers to a set of real numbers which satisfy f of y plus x minus f of y minus x is 4xy for all xy belonging to R. Now the idea is to take pangas. Okay. So we need to try different things so as to get the function. So one of the things that we generally do is put y as x. Right. So there are two variables involved. So the idea is to convert the two variables into single variables. So then since this is true for all x and y belonging to R, so I can take y as x also. So if this is true for x and y, any x and y, this will also be true when y is equal to x. Let us see what happens. So if I put y as x, it will be f of 2x minus f of 0 is equal to 4x square. Now mind you, f of 0 is a constant. So whenever you see f of 0 or f of 1 or f of 2, treat this as a constant, because if f of x is a function, f of 0 will have a particular value and it will have a unique value as per the definition of function. So we have f of 2x as 4x square plus f of 0. Let's say this is a constant c. Now this is 2x. Now what has happened now is the function has been converted into a function of x, single variable. Now since I am used to find the functions in the form f of x, so what I'll do is I'll replace 2x by capital X or any other variable. So f of x would be x square plus c. And in general, replace, now this is a variable, this can easily be replaced by small x also. So f of x would be x square plus c. So this is a function satisfying this functional equation. Now f of c, either it will be given in the question or we can find some ways to find the value of f of 0. C is f of 0. So f of 0, the ways are you can try and put x and y as 0. So if you put x and y as 0, you'll get nothing because f of 0 minus f of 0 would be 0, right? So in this case, you may not be able to find the value of f of 0. So this, you can write the final answer as this only, right? So this was a basic question of functional equation. So we were trying to reduce the function in the standard form out of these functional equations, right? Now you can also verify this. So if you put f of x as x square plus c in this, you'll get LHS is equal to RHS. All right, moving on to the next question now. Find all the functions where f is a function from real positive to real positive, satisfying f of xy is equal to f of x upon y for all xy belonging to R positive. Now this is a question. Now again, we need to try out different things. The idea is to convert two variables into a single variable. How do I do this? So one way is, if I need to eliminate y, one way is you can put y as 1. Right, so putting y is equal to 1 gives you absolutely nothing because you'll find that f of x is equal to f of x. It doesn't really help me, right? Now, what else I can do? I can put y as 1 upon x also. Because putting that, I'll get f of 1 is equal to f of x square. Or you can put y is equal to x also. Doesn't really matter. You'll get the same equation. So f of x square is f of 1. And again, as I told you in the last question, f of 1, f of 0, these are all constants. So treat them as constants only. Now, we've got a very interesting thing now. This says the function satisfies f of x square is equal to c. So that means you put any value of x here. Squaring that, the value of that function will always be c. So can I say, if this is true for all value of x, real positive, can I say f of x is a constant only? Doesn't really matter if it is f of x square or f of x, because right hand side is anyways independent of x. So fx is a constant. So this is the only function which satisfies the given functional equation. I hope you've all understood this, right? Which brings us to the last question of the evening, which says this. So find all the functions satisfying f of x plus y plus f of x minus y is equal to fx plus 6xy square plus x cube for all xy belonging to R. So f is a function from a set of real numbers to a set of real numbers satisfying this particular equation. So let me write this functional equation. So f of x plus y plus f of x minus y is equal to f of x plus 6xy square plus x cube. 6xy square plus x cube. Right. Now, what do I do in this? Now, again, the problem is there are two variables. If possible, I need to eliminate one of them. How do I do that? So one way is put y as 0. You can also try the other option that we tried in the other question, like putting y as x or y as minus x and so on. But if you put y is equal to 0 here, let us see what happens. So f of x plus f of x is equal to f of x plus 0 plus x cube. This has made our work so easy, giving function straight away as y is equal to x cube. See how simple these are. So these are basic questions of functional equations. And what I've done is I've given you the basic idea of what to do, what to try, what not to try. So these are all the ideas that we were discussing in the previous 5 questions that you all need to remember. Plus, there are other ways, other ideas also, which we will be studying in our next session. I hope you liked this session and you enjoyed that. So keep revising and let us join hands to bring gold for India.